Yes, dear students, in this video, we are doing second part of molar calculation. In this video, we will do the solving of questions from past papers. If you see, in this specific questions, I would like to explain you the calculation of moles from given mass, calculation of moles from volume and concentration, and the concept of limiting reagent. Okay, how we should know that whether we have to calculate limiting reagent or not. And the simple thing is that if you have given the information of both reagents, both reactant, one reactant is iron and second reactant is HCl. You have given the information of both. He is not saying that one is in excess. He is giving the information. Then you have to calculate the moles of both. Then you have to check which one is excess and which one is limiting. For this, first we have to calculate the amount in moles of iron present. For this, we should use this formula. Mole is equal to mass over MR or AR. As this is iron, so we will use 2.1 divided by 56. The answer of this is 0.0375. Okay. And in next, he's asking calculate the amount in moles of hydrochloric acid. We have to check what information is given about hydrochloric acid. For hydrochloric acid, it is given volume and concentration. What is volume? 50 centimeter cube. Just centimeter cube is written. What is concentration? If it is written mole per dm cube, this shows that this is concentration. So mole is equal to volume into concentration. We have volume 50, volume 50 centimeter cube. In revision checklist, we see that he's saying that you students should know how to convert centimeter cube in dm cube. Just you have to divide it with 1000. Why we have to convert it into dm cube? As the one unit is given, the unit of concentration is given in dm cube. So that's why we have to convert it into dm cube. 50 divided by 1000, multiply this concentration. This is the portion of volume, and this is the portion of concentration, 0.1. In final, we will get the answer 0.005. Now, we have the moles of HCl and moles of iron. After this, we have to see which one is in excess. In simply, if you see in equation, it is 1 mole, it is 2 mole. So for this, there is no need of a calculation. Simply, we can judge that HCl is limiting. So hydrogen gas or moles of hydrogen gas or the volume of hydrogen gas is produced according to HCl. If HCl is 0.005 mole, in equation, you see this is 2 mole, this is 1 mole. The ratio of HCl to hydrogen is 2:1. So if you want to calculate its moles, so what you have to do, you have to place, I would like to down this, yes, equation is about, in previously you have seen HCl and H2. This is 2 mole, this is 1 mole, and if HCl is 0.005, this will be 0.0025. We have the moles of hydrogen gas. If we have the moles of hydrogen gas, the formula of volume is equal to mole into 24,000 centimeter cube. Why we have written here 24,000 centimeter cube instead of 24 dm cube, as the unit is centimeter cube. So 0.0025 multiply 24,000 centimeter cube, you will get the answer 60 centimeter cube. So in this specific question, we have learned calculation of moles from mass, For example, in case of iron, and we have calculate moles of HCl when we have given the volume 50 divided by 1000. Again, I am writing here for your convenience. And concentration is given after getting the moles of HCl. We observe that HCl is limiting, so hydrogen will produce according to HCl. If HCl is 0.005, the production of hydrogen gas or the moles of hydrogen gas will be 0.0025. Once we have moles, we can calculate the volume with the help of this formula. Hope you are clear with this question. Now I would like to shift or see another question. What is another question is given? This is question paper from 2022 exam. In this question, before this, I would like to show you specimen paper. Yes. In the specimen paper, if you see what he is asking, this is the specimen paper now. Okay. Aqueous sodium sulfate is used to prepare barium sulfate in a precipitation reaction. We will explain this precipitation reaction in salts preparation method. In an experiment, 20 centimeter cube, 0.55 mole per dm cube barium nitrate is added to in an excess of sodium sulfate. Okay, you will see the sulfate and barium. Here sulfate is in excess, so there is no need to calculate limiting reagent. This question, this very specific question, is explaining previous question as well. In previous question, he has given the information of both reactant, but in this question, one information of one reactant is given and other reactant is in excess. So means if other reactant or second reactant is in excess, there is no need to calculate limiting reagent. State the color of the precipitate formed in the reaction. Precipitate will be white precipitate. We will discuss this. Calculate the maximum mass of barium sulfate that could be made from this reaction. Show your working. Okay. First, we should know the moles of barium, as he has given us 20 barium nitrate. This is showing barium nitrate, and we will see or we will calculate the mass of this barium sulfate precipitate. Once we have the moles of barium ions or barium nitrate, we have the moles of barium sulfate. How? So mole is equal to volume into concentration. Volume is 20 divided by 1000 again into what is the concentration is given. This is the concentration 0.55. Again, why we have divided this 20 centimeter cube with 1000 centimeter cube, as we have to convert the volume which is given in centimeter cube with into dm cube. Okay, now we will calculate it. 0.02 multiply 0.55, we will get the answer 0.011. So 0.011 means the moles of barium nitrates are 0.11. If barium